like the length of a good hockey game, right?
Yeah.
All right, 7.3, number 21. Find the volume of the solid generated by revolving the region bounded by the lines and curves about the x-axis. So it's important to know that we're going around the x-axis. There it is, my little hook symbol. All right, so we're going to graph y equals x, make a sketch of it. There's my y equals x, y equals 1, and x equals 0. So here's my area, and we're going to revolve that area around the x-axis. Okay, so you can imagine that this image is going to be reflected right over here, and each of the cross sections are going to look like this. Are we going around the x-axis? That's not a disk method, this is a washer method. Oh, I thought I was going to start with a disk method. Okay, they only give you a couple disk methods and they go jump right to the washers. All right. Okay, so this one is a washer. I know it's washer because there's a hollow spot, like it holds water. It's kind of like a bowl, if you can imagine that. So a washer method is integral of pi big R squared minus little r squared. And in this problem, we're going around a horizontal axis of revolution, so it's going to be dx. If we were going around the y-axis, or if we were going around x equals -2 over here, anything vertical, it would be dy. But since it's going around a horizontal, it's dx. And since we're going dx, we're going from here to right here. Well, that ordered pair right there is 1, 1. So we're going from 0 to 1. So now we have to figure out what is my big R. My big R is the distance from the axis of revolution all the way through. So that's my big R right there until we get to the other opposite side of the area. So this big circle right here, and our little r is the distance from here until it hits this side of the surface, or the area. So that would be my little r. And that's where we get our washer. It's kind of a mess here. This may make it better or worse. Not sure. There's my washer. Alright. So my big R is this distance right there, which is always 1. Doesn't matter where it's drawn, it's always going to be 1. So it's from 0 to 1 pi times 1 squared. Our big R is 1. And our little r is this distance, this distance, this distance. It's changing. But anytime you go from the x-axis up, it's always going to be y. But I can't put y there because we're integrating with respect to x. So rather than putting y, it's my equation y equals x. I'm just going to y is equal to x. So I can just put x there. And that should get you the volume of that bowl.